Hello, my name is Mason Teal, and this is my video tutorial on how to solve a related rates problem. On the left is the problem, and on the right are the steps to solve it. So let's read the problem. The police are in a car chase. They got a report of a bad guy driving north at 25 meters per second. The only way to get him, however, is to drive east to an intersection, then drive north on the street that the bad guy is on. The police decide to go 30 meters per second in order to catch up but not overheat their car. The police driver knows that they are catching up, but by how much? He asks his partner in the passenger seat to whip out his notebook and start calculating. He wants to know how much distance is being cut down as the crow flies, or direct distance, every second. Since the partner hasn't used those skills in years, he calls you to ask for help. What is the rate at which the distance between the cars is decreasing when the police car is 1,000 meters from the intersection and the bad guy is 750 meters from the intersection? So, step number 1, identify what you have and what you need. So, and also draw a picture. So, here's the picture. I drew it beforehand. So, you have the little triangle here. Here's the intersection. So, the police are driving east at 30 meters per second. And then the bad guy is driving north at 25 meters per second. And we want to know this. That's not what I wanted. The police want to know this. There we go. So now step 2 is to set up an equation. So since this is a right triangle, we are going to use the Pythagorean theorem. So x squared plus y squared equals z squared. And so there we go. Set up an equation. So now we have to take the derivative and plug in all the known variables. So we're going to use implicit differentiation with this. So we get 2x dx dy, or dz, plus, no, not dz, dt, because we're taking the derivative of time. Let's see here, okay, dt plus 2y dy over dt equals 2z dz over dt. That's a z right there. So now we got to plug in the known variables. Well, first we're going to before we plug in the known variables, we need to set up so that we're solving for what we want to solve for, basically. So we want to find the rate at which z is changing. So that would be dz dt, because that's the change in z over the change in time. So basically, we're just going to divide by 2z, divide this by 2z, and you're left with, and we're just going to erase this here. There we go. Just erase everything. There we go. So this is what we've got. This is what we're left with. So basically, now we need to plug in our known variables. So that's easy. So we have 2, I'll rewrite this, 2 times x. So x is going to be where the police car is, and the police car is 1,000 meters from the intersection. So 1,000 times dx dt, and that's the change in x, so that'd be their speed, and that's 30 plus 2 times y, and y is the bad guy, and that is 750 meters from the intersection. So 750 times the change in y, or change in time. So that'd be 25 meters per second, all over 2 times z. But we don't know z. So we need to use the Pythagorean theorem. I'll put it up top here. So x is 1,000 squared plus 750 squared equals z squared. So let me just pull up my handy dandy calculator. Do 1,000 squared plus 750 squared. It's 1,562,500. So then just find the square root of that. And we're left with 1,250. So z equals 1,250. So we just plug that in, 1,250, and that equals dz dt. So that was step 4. Solve for the unknown variables and plug them in. So now we just gotta solve it. So I'm gonna get out my handy dandy calculator again. 2 times 1,000 is 30. So we're left with 60,000 plus 2 times 750 times 25, 37,500, all over 2 times 1,250, 2,500. And so add that up, 60,000 plus 37,500. That's 97,500 divided by 2,500. And you're left with dz over dt equals 39. So it would be 39 meters per second, and that is the final answer. So the rate at which the distance between the cars is decreasing when the police car is 1,000 meters from the intersection is 39 meters per second. So that is how much z here is changing. So I hope this helps. If you do any more triangle problems like this, you'll always be left with, let me just change color here, you'll always be left with this equation right here. So you can save yourself a lot of time by just kind of memorizing that equation or writing it down somewhere, and then all you have to do is just draw the picture, plug in your known variables, and solve for your unknown, and there you go. It's all done. So I hope this helps. Thank you for watching, and have a good day. Goodbye.